before we start that, let's do a little review. Based upon your notes and your homework in the past, I to the 27 is the same as I to the what?
Negative I. Negative I.
Alright, so I to the 0. Anything to the 0 is 1. I to the 1. Anything to the first power? No. I to the 2.
Negative 1.
I to the 3 is just a combination of I to the 1 plus 2 is 3. So I and negative 1 makes negative I. So the trick to this was divided by 4, because this thing cycles by 4s. I to the 4th will go back to equal 1, I to the 5th will equal I, and so on. So without actually counting from 3 all the way to 27, we know since this goes in groups of 4, we can divide this by 4, and then we have a remainder left over. What is that remainder? So if you divide by it, you get 75. So remember, we're dividing by 4, so 3 divided by 4, that's how you get the 0.75. Anytime you get a 0.75 decimal, that means there's a 3 remaining, because it's 3 out of 4. So this is the same as I to the 3rd, which equals negative 5. If you divided and you got 0.5, that means your remainder was 2 out of 4, 0.5, so your answer would be negative 1. If you got a decimal of 0.25, that's 1 out of 4. And if you did not get a decimal at all, or 0.0, that means your answer is 1. So let's talk what we're going to do. Write it down. We're going to go back to where we started this week, quadratic formula. Only we're going to insert in all these imaginary or also called complex numbers. Okay. We're going to look at the discriminant, which is really just a part of the quadratic formula. It's a part underneath the square root. We'll look a little closer at this because it's going to tell us information without actually doing a lot of work, which could be useful. So we'll look at this and what it means and decide within the quadratic formula. So before we begin, though, let's review graphically what everything means. How many solutions does this have?
1.
How many?
1.
1, because it intersects x-axis 1 time. Okay, right there. And when you have one solution, it's true that the vertex is also the x-intercept. That only happens when you have one real solution. And then how many solutions do we have here? 2. Once again. They intersect at 2 places. So all those quadratic formula problems you're doing, when you got 2 answers and 1 answer, graphically they mean where do they actually cross. Okay. Now, in the past, how many solutions has this been? 0. Okay. This is what it has changed. Before we said no x-intercept, so there's no solutions. Really, that meant there's no real number solutions. Not that there's no solutions ever. But you might have noticed along the way, you might have noticed that they said no real solutions. Even the back of the book is careful when they say no real solutions. I mean, there's no real numbers that are solutions. However, there are complex or imaginary solutions. So for now on, remember, you are not going to say no solution anymore, simply because there's no x-intercept. This actually has 2 imaginary or 2 complex solutions. Okay. So our 3 options are now 2 solutions, 1 solution, 2 complex solutions. So you will never say no solution any longer. So how can we figure out before, without doing any factoring, without doing any quadratic formula, how can we figure out if you have 2 complex solutions or one real solution, or two real solutions. That's what this discriminant value is going to tell us. Without actually doing the whole quadratic formula, we can find that out. That's the big picture for today. Is how do we know that just by looking at this value? When we plug in A, B, and C and get an answer, how can we tell which of the three possibilities, two real, one real, or two complex solutions? So here's the gist of it. Let's see what's up here. Here's what's in the book. Find this in the textbook. It basically says, I mean, it's a lot of information, but if you look at the graphs first, it's just what I just showed you. There's three possible graphs, two solutions, one solution, and two complex solutions. Not no solution. When do you get I? After everything we've been doing, when do you get the value I? When what? When what's in the square root? A negative. Yeah. So anytime we get a negative in the square root, that's when we get the complex. So whether it's -1 or -4 or -99, it doesn't matter. Every time we get a negative inside of the square root, that's where the I value comes from. And since we have an I, that means it's complex. So anytime this discriminant value, the part inside the square root, anytime that's negative, that's how you know you're going to get two complex roots. And that's also how you know graphically you're not going to have any x-intercepts. So if you have two complex roots, you have no x-intercepts at all, no matter what. When do you get one solution? It turns out you get one solution when the part inside the square root, you take the square root of b squared minus 4ac, and you get 0. Because, well, what is 4 plus or minus 0 over 2? What's 4 plus 0? 4. Divided by 2? 2. What's 4 minus 0? Over 2 is 2. Yeah, you got one answer. You got 2 for both of them. So this happens every time this discriminant square root comes out to 0. It's because when you do 4 plus 0 and 4 minus 0, you get the same thing. You get 4. That's why we get only one answer, because they're both the same. And of course, the other case is when this was when the square root was negative. This is when the square root is 0. So when you get two real solutions, when the square root is positive. If the square root is positive, it's going to be like, 4 plus or minus 16 over 2. Like most of our problems end up looking like that. You got a positive discriminant, and you got two solutions. So it'd be like 4 plus 5 over 2 and 4 minus 5 over 2. We get two answers. Even if it's irrational, it's 4 plus root 17 over 2, or 4 minus root 17 over 2. You still get two answers. They're going to be, decimals, they're going to be irrational, but you still get two real answers. So that's how we're going to tell. If ahead of time, before we actually do the whole problem, if we have two answers, two real answers, one real answer, or two complex. And that's the big shift from what we know before. Before we'd say no solution. Now we're going to say two complex solutions. And besides this, everything else is the same as Monday. We're going to have to do a little work with the I's so we can write our answer correctly when we get complex solutions. We'll go over that. But other than that, it's going to be basically the same. So this is your key to everything. So kind of like that, I would say, this chart right here, how this was really valuable 2 days ago for pretty much answering everything. That's what this is tonight, or this weekend. Knowing that positive square root, two reals, 0, one real. Square root of negative, obviously you're getting I, so that's how you get the two complex. And remember, complex numbers always come in pairs. So you can have two complex roots. Later on in classes, you'll have like 4 complex, but it's impossible to have 3 complex roots or 1 complex root, because from your homework last night, you saw every time you got complex roots, you always had a plus or minus. Like plus or minus 2i. So these are your two roots. One's positive, one's negative. So complex roots always come in pairs. Awesome. So let's do a few examples. You can watch me on this one, or you can write it down and you can follow. But I'd rather have you watch and understand. So this will be the same exact thing as from the book, from your homework. Find the discriminant. Say what type of root. So this is the 2 reals, 1 real, or 2 complex, and then actually do the quadratic formula and get our 2 answers. On these, I only want the exact, meaning we don't have to go through into the decimals and plug in the approximate answer. We just have to do the exact. So on your homework, make sure you label it. You start at part A, find the discriminant. That's always going to be that part of the quadratic formula inside the square root. I always suggest the next step, after you write the formula, write with open parentheses. Many people that had to read you a few problems, you had 95% of the work correct, but because you didn't use parentheses, you missed a negative, and that's why everything after this blank was incorrect. But all the algebra, all the steps were right, but just a negative was wrong throughout the whole problem. So it seems trivial, it seems like not a big deal, but really that's where most of the problems come from, because people think it's not too important. So A, B, and C. What's A is equal to, B is equal to, and C is equal to? Very good, -6. So you do have to subtract, you have to get this equal to 0 before you start. So that rule, we got to get equal to 0 before we start. So A is 1, B is 6, C is -6. 6 times 6? 4, -4 times 1 times -16 is 64 minus? Positive. -4, -16. Alright. There's equal signs here. That equals 100. Alright. Part B next. How many solutions? What kind? 2 real. Nope. Third real. What, how do you know this again? What's giving this away? What about 100 lets you know it's 2? No? It's positive. Yeah, it's the fact that it's positive. What does 100 have to do with this answer? Nothing. It's the fact that it's positive that it's 2 real roots. The fact that it's 100 or positive 17 or positive 1 million, it doesn't matter. It's the fact that it's positive that it's 2 real. Numbers are not important in this problem. So now let's actually do the quadratic formula. Okay, here's the nice part. You already did part of it. D is the discriminant. That's what we found in part A. So we already know this whole thing underneath the square root, b squared minus 4ac, equals 100. So I only need to really plug in 6 plus or minus 100 all over 2 times 1. It's nice because it kind of makes the problem seem a lot easier and faster. We don't have to do all that work. Or, not that we don't have to, we already did all that work. Right, so we have -6 plus or minus square root of 100 is 10. All over that one. Okay, let's get our two answers. Negative 6 plus 10.
4.
4 over 2. Negative 6 minus 10. Negative 15. And then one more step. 4 over 2. Negative 6 over 2. Lastly, put our answers in braces. So we know our x equals 2 or 6. Do not use parentheses. Do not use parentheses. That would mean our answer would be at 2 comma negative 8. Doesn't make sense. So as you can see, what's really new here? Part B. Like I said before, that chart that we just looked at, this is the new part that we're really focusing on. Afterwards, it's the same thing we started with on Monday. You guys were doing 8 of these on Monday's homework. Okay, we're going to do about 3 or 4 more of these just to see every case. So this is one that has 2 real solutions. We'll look at when it has like an irrational solution, and we'll look at when we have a 0 for discriminant, and we'll look at one negative. First of all, before we move on, what does this mean?
That's your real solution.
What does that mean?
The act.
Yeah, these are axes and
Roots.
So I want you to always be keeping in mind what your answers mean. Not just, okay, it's 2 negative 8, okay, next one. It means if we graph this, it'll go through negative 8 and positive 2 on the x-axis. This is why. What is the center? What's the exact middle of negative 8 and positive 2? So negative 8 plus 2 is negative 6. Negative 6 divided by 2 is negative 3. So negative 3 is called our
Vertex.
yeah, line of symmetry.
Symmetry.
So if you wanted to, you can go through the formula, which was negative b over 2a. Notice how that's this. Right? So your axis of symmetry is negative 6 over 2, which equals negative 3. Same thing. If we plug in negative 3, we'd find out that if the vertex is at negative 3 comma negative 25. What's the y-intercept here? Negative 16, whatever c is, right? That's the y-intercept. So we know on the y-axis, the intercept, this is negative 25. I'm just estimating. I'll say this is negative 16 right here, which also means over here is another negative 16. So everything we're doing right now today, even though we're not doing all the graph, I want you to understand it's just a small, getting this answer is just a small part of a much bigger problem. Being able to graph a parabola. Okay. So we started off with this again last week with graphing, and we're still working on the exact same problem. So really, starting from the test last week on, we took it on Tuesday. So starting on Wednesday all the way to today, we've only been working on one problem the whole time. We factored some last week. We can factor this. You know, what two numbers multiply to negative 16 and add to 6?
8 negative 2.
Yeah, 8, negative 2. Right? It's the same thing we've been doing the whole time. Right? So we have x plus 8 and x minus 2 right, equals 0, and then you get, you know, what plus 8 is 0? X equals negative 8. What minus 2 equals 0? X equals 2. You still get the same answers, the method we did last week. Now, you might want to take note, look how much faster it is to factor on this solve. We just did all this work right here. This took like 2 steps, and I got negative 82. The downside is factoring doesn't always work. When you have some nice numbers like 8 and negative 2, that's great. But if we did all this work and our answer came out to x equals -3 plus or minus root 17 over 4, there's no way you get that factoring. So yeah, factoring is quick, but only when it works. And it only works maybe 20% of the time. So that's why we have this other method. This other method is longer, but it always works. All right, so that's the big picture. These are all x-intercepts. Except when they're complex, then they're just called complex roots, and there are no x-intercepts. So let's try another. You guys do a little bit of this one, then I'll do a little right after. So go ahead and write this down. X squared minus 16x plus 64 equals 0. Get a little practice in. We have our discriminant. We got to know that's the part inside the square root of the quadratic formula. I'll let you go from this point on. Once you guys go ahead, see what you get, and then see what your answer is for part B. Lay down your own, I'll walk around to see if you can have any questions. But give it a shot. I know it's going to seem like, oh, we've been doing this forever. Why do we have to keep on doing it? It's worth it. It's not trivial. If everybody was getting 100% on every one, we wouldn't be doing it. But ironically, the mistakes are not algebra. They're usually forgot a negative or multiplied wrong on the calculator. Usually, you know what you're doing. It's something else, something other than that.
Oh. You get 0. I got 163.
Yeah, check the sign around you, see what you get. Settle.
You got 0 too?
You get so excited.
Yes. Excuse me, where are you going? I'm sure a lot of people like calling it.
I don't care.
Is it not just how
Always burn the house down.
Yeah.
Not wishing him happy birthday. I promise you I won't sing it. Nobody's gonna make you.
Alright, I got 0. What does that mean? It's unreal. When you solve it, what do you get? -16 plus or minus root 0 from part A. That's the same. And then all over to times 1. So we get positive 16 plus or minus 0 all over 2. So our answer is 8. So notice how our number of answers in part C should match our answers in part B. We say we get one real in part B, we better make sure we get one real number when we actually solve it. So these need to match. Okay, so lastly, what does this mean if we did graph it? Yeah, there's one answer, so it looks like this. What's the vertex? A, comma, 0. So you notice when you have one solution, your x-intercept is also your vertex. So they're the same when you have one solution every time. If we graph this high enough, like way up to 64, that's the y-intercept, it's going to eventually cross right at 64. So when you have one real solution, it's actually a little easier to graph because the x-intercept and the vertex are the same. We don't have to do the part B and do the x sub b, and you don't have to do all this work if you know ahead of time. That's one of those things, how's that person finish that test so fast? They must be really fast at math. It's like, maybe they just know this. And when you're busy doing all this extra work, they already know, I don't need to do it. It's the same. So it's a piece of information that's making it clear. Not that they're just doing the same thing as you faster. Okay, just a few more. And of course, as you go along, you'll notice yourself getting faster at these. That's a good thing. If you notice yourself getting bored at these, but you're getting them right, that's a good problem to have as well. So that means you can do them when you're not really thinking too much as you're doing them. It's pretty automatic. Still. So B equals 5. C equals, oh, A equals, 3. And C equals 1. So we get, all right. So for B, what do you get for B? 2 real. How come? Positive. Does that have anything to do with 13? No. Positive, 2 real. X equals negative B plus or minus the square root of the discriminant. All over 2 times A. Question? Anything else? Almost done though. So we have negative 5 plus or minus square root of 13, discriminant, all over 2A. Negative 5 plus or minus square root of 13 all over 6. Now, this is the exact solution. If the directions say exact solutions, here it is. If they say to approximate, that's when we have to go through and get all those decimals. And I believe on this homework, it just asks you for the exact. Those are, I just want to make you understand that this right here is 2 solutions. It's negative 5 plus root 13 over 6 and negative 5 minus root 13 over 6. There are 2 solutions right here. So it does match what we thought it would in part 1. Lastly, and we're done. Let's do one where the discriminant comes out to, which one have we not covered so far? Hey, yeah, let's look at our last example when we actually get a negative discriminant. Go ahead and, by now you might be able to go through this faster than me. So I'll take my time. Now the last few have all been equal to 0. Just make sure the ones that you work on are equal to 0 and in descending order before you start. So B is negative 6, A is 1, C is 10. So this equals 36 minus 40. Which is negative 54. Part B. What do we got? 2
real.
complex. Why complex?
That's negative.
Negative. Yes. Nothing to do with 4. Negative complex. Which means we're going to be taking the square root of negative. That's where the complex comes from, because this is the side of the square root. So there's negative, that's where you get the I. We have x equals negative b plus or minus square root of our discriminant all over 2a. We have negative 6 as the b. Discriminant is negative 4. A equals 1. A is 1. Positive 6 plus or minus I root 4. So take out the negative. making an I. Where the complex roots come from. Square root of 4 is
2.
2. So 2. I. 2. Lastly, distribute the 2. 6 divided by 2, 2 divided by 2, 3 plus or minus I. How many solutions are right here? 2. Yeah, 3 plus I and 3 minus I. So it does match our part B. So every time we have a negative discriminant, we have a negative square root, which means we have an I, which means we have complex. So all this is all connected. You can see, I mean, if you look at this as a whole, there's not that much work for each problem. But as soon as you say it's not that much work, therefore I can skip all these steps because I can do it faster, that's where the problem comes in. Do not rush through it and say it's not worth doing the little things like the parentheses. Because many people will miss this negative of a negative 6 and so on. Keep that in mind. All right. Good luck.